Hello, super scientists and curious kids. Have you ever looked up at the big, beautiful sky and wondered, why is it blue? It's one of nature's most amazing magic tricks, and today we're going to uncover its secret. Get ready for some awesome discoveries. First, let's talk about light. The light from our sun looks white, right? But guess what? White light is actually made up of all the colors of the rainbow, all mixed together. Think of it like a secret code of colors. When you see a rainbow, you're seeing those colors separated: red, orange, yellow, green, blue, indigo, and violet. Each color travels in tiny waves, and each color wave has a different size. Blue waves are much smaller and choppier than red waves, which are long and smooth. Now, let's talk about our Earth. It's surrounded by a blanket of air called the atmosphere. This atmosphere is full of tiny, tiny things we can't even see, like air molecules and dust particles. They're super small, but they play a giant role in our sky. Imagine millions of tiny bouncing balls floating all around you. That's a bit like our atmosphere. When sunlight travels from the sun to Earth, it has to pass through this incredible atmospheric obstacle course. So, here comes the sunlight, full of all its rainbow colors, zooming towards Earth. When these light waves hit those tiny air molecules in our atmosphere, something spectacular happens. The light gets scattered. It's like the light waves are bouncing off the tiny particles and going in all different directions. This scattering is super important. Not all colors scatter the same way. Remember how blue light waves are smaller and choppier? Because they are smaller, they bump into those tiny air molecules much more easily than the longer, smoother red waves. Because blue light waves scatter so much more, they get bounced around in every direction across the sky. So, when you look up, you're seeing all that scattered blue light coming from all over. It's like the atmosphere is a giant blue paint mixer, spreading blue everywhere. Other colors like red, orange, and yellow have longer waves. They don't get scattered as much by the tiny air molecules. Instead, they mostly travel straight through the atmosphere and come directly to your eyes. But wait, if the sky is usually blue, why do we sometimes see amazing red, orange, and pink skies at sunrise and sunset? This is another awesome part of the light scattering story. At sunrise or sunset, the sun is much lower in the sky. This means the sunlight has to travel through a lot more of the Earth's atmosphere to reach your eyes. More atmosphere means more scattering. During these times, nearly all the blue light gets scattered away long before it reaches you. What's left to travel straight to your eyes? The longer wavelength colors like red, orange, and yellow. That's why we see those fiery, beautiful colors painting the sky. What if Earth didn't have an atmosphere? Then there would be nothing to scatter the blue light. If you were on the moon, for example, the sky would always look completely black, even when the sun is shining brightly. Astronauts see a black sky from space because there's no atmosphere to scatter the sunlight. It really makes you appreciate our incredible atmosphere, doesn't it? So the next time you gaze up at the big blue sky, you'll know its secret. It's all thanks to the sun's white light, our amazing atmosphere, and the way blue light loves to bounce and scatter. Isn't science wonderful? It's amazing how simple things, like tiny air molecules and light waves, can create such a spectacular view every single day. Keep looking up and keep exploring, super scientists!